So let's talk about a story that absolutely rocked the world of mathematics. It's all about an AI that supposedly solved one of those famously tricky Erdős problems. You know, those super elegant but incredibly difficult puzzles from the legendary mathematician Paul Erdos? This one had stumped humans for 30 years. But as you're about to see, the real story, well, it's even more fascinating than the headlines.
And this was the vibe, you know? The announcement just hit like a lightning bolt. Suddenly, social media, forums, everything was just buzzing. For a minute there, it really felt like something fundamental had changed overnight. And boom, the reaction was immediate and explosive. All of a sudden, you see these headlines calling it a moon landing moment for AI. The story was so simple and powerful. A machine, all by itself, cracked a puzzle that had baffled the smartest people for 3 decades.
Okay, so let's start by digging into that first, right? The big, flashy, moon landing version of the story. What exactly were the claims that made this feel like such a huge deal?
So here's how the story went, right? An AI, apparently called Aristotle, solves this ridiculously hard math problem, and it supposedly did it completely on its own, 100% autonomous. The proof it came up with, verified as correct in just 60 seconds. Zero human help needed. It sounds like something straight out of a movie, doesn't it?
It's a great story, an incredible story. But is that what really happened? As with most of these huge breakthroughs, the truth is a little more complex, and honestly, a lot more interesting.
All right, this is where it gets really good. Let's peel back those layers of hype and get to what was actually going on. Because what truly happened here tells us something profound about the future of discovery itself.
And to help us get to the bottom of it, who better than one of the greatest living mathematicians, the Fields Medalist Terence Tao? He looked at this and said, yeah, the solution is cool, but the real breakthrough? That's something else entirely.
And this, right here, just lays it all out. The hype was the story of a lone AI genius, a thinking machine. The reality? It was a powerful team-up, a collaboration between a human and an AI. The AI wasn't thinking on its own. It was acting as this brilliant translator, taking a human's informal ideas and turning them into rock-solid formal logic.
And that gets us to the absolute heart of the matter. This wasn't a story about replacing human brains, it was about amplifying them. We're seeing a new kind of partnership take shape, and this was one of its first big wins.
So check out this new workflow. It's actually a 3-step dance. First, it starts with a human expert. They write out the core ideas of the proof, just in plain English. Then the AI, Aristotle, steps in and translates that English into a superstructured formal language called lean. And finally, a totally separate system checks that lean code to make sure every single logical step is perfect.
Okay, so you might be asking, what exactly is this lean thing? It's not a creative AI. Think of it more like an incorruptible referee. It can't invent a new play, but it will spot a foul with 100% accuracy. If you can write a proof in its language, lean can tell you with absolute certainty if it's logically correct. It's built for one thing, logical perfection. And that is the secret sauce. You know, we hear all the time about AI hallucinating, just making stuff up. Well, in this workflow, that lean checker acts as the ultimate filter. It simply will not accept a flawed or hallucinatory argument. The end result has to be pure, cold, verifiable logic.
So, if the big breakthrough wasn't an AI that could think like a person, then what was it? This is where we come back to Terence Tao's big insight, the part he found even more exciting than the solution.
And here's the thing you really need to get. Solving this one specific problem, that wasn't the point. It was just the demonstration of a completely new way of working, a new way of doing science.
And here it is, right from the man himself. The real game changer is the AI's ability to rapidly write and rewrite a proof. It's about iteration, but at a speed and scale we've never seen before. It's not about the AI getting the first answer. It's about its ability to create the second, third, and 10th versions of that answer, almost instantly.
So why is that such a game changer? Well, because that's what science and discovery are all about. The AI can rephrase an argument in a split second, and in doing so, reveal hidden assumptions or tiny logical gaps you missed. It's like having a co-writer who not only catches typos, but can rewrite a paragraph 10 different ways, helping you find the clearest, strongest way to say what you mean. This frees up the human to focus on the big, creative ideas, while the AI handles all the tedious verification and refinement.
Okay, so let's zoom out. What does this all mean? Where does this new partnership between human creativity and machine rigor actually take us? Because make no mistake,
this is way bigger than just math. What we're looking at is a grand new template for solving really, really hard problems in any field that requires perfect logic, from software engineering to theoretical physics.
I mean, just think about the possibilities. We could use this to formally verify the code in things like airplanes or medical devices, making them practically bug-free. We could accelerate physics research by rapidly testing complex theories. As Tao said, it's about lighting up that dark forest of unsolved problems, letting us go after challenges on a scale we could only dream of before.
And that really brings us to the big final question, doesn't it? The story was never AI replaces the human. The real, much more exciting story is that we're at the dawn of a totally new kind of partnership. So the question we should be asking is, what becomes possible now? What grand challenges in science, in technology, could we finally solve when the best of human creativity is amplified by the speed and infallibility of a machine?